Okay, so in this video I'll be going over how to convert between binary and hexadecimal. So there's two ways you can kind of do this. There's an easy way and kind of, I guess, the standard way that's kind of, it'll work, but it's kind of a little more work. So I'll go over the longer route first. So let's take, for instance, let's say we've got the number 100111110. So that's four, okay. And base 2. And we want to convert this thing into hexadecimal. And what hexadecimal is, it's base 16. So the long way we can do this is we can figure out what this number is in base 10. So this thing's going to be, here's 2 to the 0, here's 2, 4, 8, 16, 32, 64, 128. So we have 128 plus 16 plus 8 plus 4 plus 2. So I'm just going to plug this in my calculator. 158 is what this turns into. So now the way I'm going to lay this out, I'm going to put our placeholders down. So here's 16 to the 0, here's 16 first, and then I don't think, yeah, we're not going to go out to 16 squared, but I'll put it down anyway. Here's 256, here's 16, here's 1. So the way hexadecimal works is you can go all the way out to 15. Because in binary, you have either 0 or 1, and base 10, you have 1 through 9, and base 16, you have 1 through 15. So what ends up happening after 9, you'll have 1 through 9, and then you have A through A, B, C, D, E. I think it's F. Yeah, F is 15. So A is 10, F is 15, and you count in between for all the others. So we've got 0 here because there's no 256 doesn't go into 158. Now we just want to figure out how many times 16 goes into 158. So we can just take 158 divided by 16. And so we get 9.875. We're going to round down to 9. So we're going to end up with 9 here. So 9 times 16 is 144. So we're going to take 158, subtract 144 from that. We're going to get 14. And so we're going to have a 14 here in this slot. So we're going to have A, B, C, D, and E right here. So this number here, 1001110 in base 2, is 9E in hexadecimal. So there is an easier, kind of faster way to do this when you're going from base 2 to hexadecimal. So we'll do this exact same example here on another page. So, I guess I better remember 100 1001111 0. I'll group that over there. So here's our same number. So the way you can kind of think of this, if you're dealing with binary to hex, you can kind of group up stuff in groups of 4. So here's a group of 4 numbers, and here's another group of 4. So we can add these all up. We can think of this still as our 2's place, or our 1's place. 1, 2, 4. Come on. 4 and 8. So we're going to add this all up. This is 12. This is 13. So what's 13 in hex? That's A, B, C, D. So this will be D. Uh-oh, that's not good. It should be E. Oh. Oh. Yeah, this should be D. This is 14. That's my bad. Whoever's watching this is probably going to be yelling at me the whole time for that. But yeah, there should be a D, right? Because A is 10, B is 11, C is 12, D is 13. Nope. E is 14. Okay. Yeah, I'm an idiot. Just had to write that out. Nope, forget that. This is E. This is 14. 12. No, this is 13. What the heck's going on? 12, 14. Oh, jeez. Yeah, this is 14. Holy cow. Should I remake the video? Who knows? This is 14, so what's 14 in hex? That's E. Goodness. Okay. And then we're going to do the same thing over here. So instead of this being 16 here for this spot, and this being 32 and whatnot, we're just going to reset and say this is our 1's place, 2's place, 4, 8. Now just add this up. So we're going to have 8 plus 1. We're going to have 9. And so that's an easier way, even though I didn't make it out to be that way. This is an easier, quicker way to go from binary to hex. So I guess I'll do one example where we go from hex to binary. I'm not going to have a huge number here because if we're going from hex to binary, the binary number is going to be pretty big. So let's just do that's still going to be big, but 2A. Let's do that and convert this into binary. So let's figure out what this thing is in decimal first. So A is 10, so we're going to have, this is our 16 to the 0 spot, and this is our 16 to the first spot. So we're going to have 10 times 1 for that spot, and then we're going to have 16 times 2 for the other. And so we've got 32 plus 10, so that's 42. So now let's lay out all our placeholders for binary. 2 to the 0, 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth. Let's see here, 2 to the fifth is 32 to leave, right? 2, 0, 1, 2, 4, 8, 16, yeah, 32. So here's 1. So now we've got 42 minus 32, leaving us with 10. So this is 16. We're going to put a 0 here. This is 8. We're going to put a 1 there. So there should be 2 left. So 1 here. Everything else is zeros. This should be right. Let's double check. 32, 16, 8, 4, 2, 1. So right, we're going to have 32 plus 8. That's 40. Yep, that should do it. So that is converting between hex and binary and vice versa.